So some of you asked for homework questions 106, 114, and 113. I'm going to try to do all three of them. 106 is a system using logs. So you have log base 2 of x minus log base 2 of y equals log base 3 of 1/3. And then your second equation is 2 log base 4 of x plus log base 4 of y is equal to log base 7 of 49. It would be nice if we could actually use elimination here, like eliminating these terms, but we can't because the bases are not the same. So it might help us, the first thing, just to condense each of these and see what happens when we condense them. So if we end up condensing, we get log base 2 of x over y is equal to log base 3 of 1/3. Alright, it's on the side. Log base 3 of 1/3. This is equal to -1. So we can substitute -1 in here. And then if we translate this into exponential form, we get 2 to the -1 equals x over y. And 2 to the -1 is 1/2. 1/2 equals x over y. Alright, so we know 1/2 is x over y. Now let's do the second equation, see what happens with that. Let's condense it, so bring it back. Log base 4 of x squared, because of the power property. You're bringing the 2 back. And this is times y equals 2. If we use the, if we translate this in exponential form, switch, we get 4 squared equals x squared y. Another way of saying this is 16 equals x squared y. Okay, so we have two different forms now. And it might help us to actually use substitution here, or we could do a couple different things. We want to substitute. How about we start here and get our y alone? So to get our y alone, or get our x alone, we'll multiply each side by y, and we end up getting solution for x. X equals 1/2 y. And now that we have this, we can take this 1/2 y, substitute it in for x. Oops. And then we will get 16 equals 1/2 y squared times y, which gives us 16 equals 1/4 y to the 3rd. That doesn't seem to come out right. Oh wait, so we'll multiply each side by 4, so that will come out right. Multiply by 4 and by 4, we get 64 equals y cubed. Take the cube root, y will equal 4. So we know that y equals 4 after all that work. Okay, now that y equals 4, we can go back in and find x by plugging 4 in to y. 4 times 1/2, x will equal 2. Alright, so x equals 2 and y equals 4. So I guess the main point here in this problem is you're doing a couple things. You're condensing the logs, and then after you condense, you end up isolating for x, which is what we did here, and then you end up substituting. Alright, so I hope that helps with 106. Let's move on to 113. 113, trig problem coming back. Really important. Concept you should know: final values of theta, or theta, The domain is from 0 to 2 pi. A is asking for cosecant theta equals 2 over rad 3 over 3. So now we're kind of going backwards. The question is, where on the unit circle is the cosecant equal to this? To think about this, we need to translate cosecant to 1 over sine of theta. These are the same thing. 1 over sine of theta would equal 3 over 2 rad 3. And then what we could do here, actually, yes. So what we could do here is multiply here by rad 3 over 3. And I've actually flipped this already, so this right here is equal to sine of theta, because I flipped it. Once we multiply, we get 3 rad 3 over 2 times 3, which is 6. And if you simplify this, you get rad 3 over 2. So the question is, where is sine of theta equal to rad 3 over 2? Sine is your y coordinate. So where is y coordinate? Rad 3 over 2. There's 2 locations. Theta will equal the unit circle if you visualize it. It's going to be 2 spots. It's going to be rad 3 over 2 is going to be here. It's also going to be here. Pi over 3 and 2 pi over 3. Alright, same concept with B. We go back, look at secant. So B, it gives you secant of theta is equal to negative rad 2. If we flip this over, this time we'll just go straight to cosine of theta. Will equal 1 over negative rad 2. You got to rationalize this. So multiply by rad 2 over rad 2, which will give us, the negative will come up top, negative rad 2 over 2. Where's your x coordinate equal to negative rad 2 over 2? There's 2 spots on the unit circle. It's going to be here and here. Theta will equal 5 pi, or actually, excuse me, I drew that wrong. X coordinate, so there'll be negative here and here, which will be theta equals 3 pi over 4 and 5 pi over 4. Alright, so that's B. C, where is tangent undefined? Tangent is undefined. It will have to be, tangent is sine over cosine, and the only way you can have something undefined is if the denominator is 0. So the question becomes, where is cosine equal to 0? Cosine is your x coordinate, so where's my x coordinate? 0. And that would be, we look at our unit circle, our x coordinate is 0 in 2 places. Here and here, which is pi over 2 and 3 pi over 2. Let's C, and in D, gotta do the same thing here, except with cotangent. Cotangent of theta equals negative 1. Cotangent is cosine over sine, which means we have to have these match. The only place these match at are the rad 2 over 2. So on our unit circle, it's got to be negative also, so we can draw it out. Tangent is only negative in quadrants 1 and 3. So we're going to be negative here and here. And actually I should have read this is a Roman numeral here. 1 and 3. And this point here, this one, this is pi over 4. And then this point down here is 5 pi over 4. Okay. Actually, that's where tangent's positive. I made a mistake on that. Tangent is negative That's where tangent is positive. Tangent is negative here. 3 pi over 4 and 7 pi over 4. Because tangent is negative in quadrants 2 and 4. It's positive in 1 and 3. Alright. So I hope that helps looking at those. And the last one is 114. Let me pause for that and bring this up. Alright, so if 114's great problem, it's going to look a lot like our lab. It asks you to write an equation for each of these sine curves, or cosine. You can write sine or cosine. Just know that sine is going to start at the middle and cosine will start at the top. I think for this one, cosine's easiest because if you look right here, we have kind of our starting point and there's no horizontal shift. This graph would be cosine. Let's find the midline. Midline's going straight through here, which is going to be -1. You can see that our amplitude is a stretch of 3. And then we have to figure our period length. You can see that there's 1 cycle here, 2 cycles here, so there's 2 cycles in the length of 2 pi. So our angular frequency will be 2. Another thing we can think about this, if the period length here is just pi, some of you probably work better this way. We need to find b, our angular frequency, so b equals 2 pi over pi. Cancel out the pi's, b is equal to 2. Alright, so we know that this equals 3, you know, this is my k-shift. Now we can go ahead and plug in into our equation. So y equals 3 cosine. So let me give it a little bit more room here. Y equals 3 cosine of 2x. That's my b. So there's my b. There's my 3. Minus 1, there's no horizontal shift, and cosine means I'm starting at the top. Okay. Now you could also write an equation here for sine, but you would have to keep in mind that sine, it's going to be almost the same thing except it has a horizontal shift of, that looks like 3 pi over 4, so you're going to have to shift that in the equation. The second one, how about we do that? How about we make it a little bit harder on ourselves and write an equation for cosine here? Actually, let's do it for sine, but let's start from here. So for this, we know that our k is 0. That's our midline. We know that our amplitude is 2. And then, since we're doing sine, we're starting here. We're going to have a horizontal shift. And then our period length, it looks like it's 4 pi, so we can solve for b. b equals 4 pi over, 2 pi. 2 pi over 4 pi, cancel, we get b equals 1/2. So now when we write our equation, we'll get y equals, our amplitude is 2, we're going to do sine, and we have 1/2. Now we have x minus 2 pi because it's my shift, and then we have at the end, actually that's the final equation because there's no vertical shift. Now that's starting from there. It would have been a lot easier if we would have made the function start here. There'd be no horizontal shift, and the only thing that would change here, it'd be a negative sign because it's going down. Alright, I know that's 3 homework problems pretty quickly, but I hope you can look back and pause it and figure things out. Thanks for asking these questions, and I hope this helps.